Good afternoon. Everybody's back from lunch? If you're not here yet, be sure to let me know. Raise your hand or something like that. How are you enjoying RootsTech so far? Great. Wonderful opportunity that the community has come together and put this all on. And I'm happy to share with you some things we've learned over the years in working with databases. That is essentially what we do nowadays in genealogy, is we look at databases. The databases might be manual in a few cases, an old database of a card file, for instance, from the 1930s on microfilm. But by and large, we're looking on the internet. We're looking at databases maybe in our own data files or in a library, perhaps, or something of that nature. And there are a wide variety of ways in which to search those databases. And so we wanted to introduce to you and make sure you're aware of some of those different ways to search those databases. Not all databases can be searched in the same way. Some databases have severe limitations on the search algorithms that are allowed. Some of them have a wide variety of opportunities. None of them can support all of the different tactics we're going to talk about today. But all of these tactics are used in some genealogical databases in one place or another. So let's talk about getting the most we can out of these genealogical databases. I want to first set some ground rules. We're going to essentially divide the world of genealogy databases into two big camps. They're close cousins to each other. They work well with each other, but there are differences, okay? There's a wide variety of databases. Ancestry alone has some 35,000 or more databases, with more being added virtually every day. But each database takes different searches and different techniques, okay? Databases can be seen either as fielded data. This is the kind of data you put in your own genealogy database manager, whether it's PATH or RootsMagic or Legacy or the Master Genealogist or a dozen others out there. Fielded data means all the information is in one field or another. The person's name is in a name field, or maybe in two name fields for given and surname. The dates are in their own fields, locations, whatever data you have there is in a field. And those were invariably created by human data entry at some point in time, putting that data into a software program. It might date back to the 1960s and the federal government doing data input in Social Security materials. It might date back to last night when you put new data into your own personal database manager. But either way, fielded data had to be handled by somebody's hands or fingers and keyed into a field, by and large. We also have textual databases. Textual databases are essentially either electronic text of one type or another. That electronic text is usually converted two ways. Either they took the printed material from an old newspaper or a book or something of that nature, and they scanned it into a computer, and then let the computer do the hard work of figuring out what all those images meant and turning all those images into digital letters and numbers, which we call optical character recognition. It's a way to turn text into electronic text, images of text. And of course, it can also be possible that people just simply keyed in, hand wrote by keyboard, a lot of the information. For instance, at a lot of different county RootsWeb pages, US Gen Web pages, people have keyed in parts of a county history. Maybe the biographical section, the Kentucky state has done a lot of this in their counties, where they've keyed in biographical data right there from a county history, and they've posted that on their county Gen website. So those are the two kinds of databases I want us to have in mind. Textual database where electronic text is there, and fielded data where the data is electronic but is in different fields, and therefore we call up the fields and we search on those fields. Is that pretty clear to everybody? Match your experience, okay? All right, then. These are the dozen different ways that I've identified over the years of ways searches can be conducted in various databases. And we'll go through each one of these, talk about the difference between keyword and phonetic and field searching and limiting searches, all those other opportunities that are out there. And so let's just start, okay? First one is, of course, keyword searching. And keyword searching is one that most genealogists are fairly familiar with. They use it all the time, where you simply pick a keyword that best describes the information you are looking for. You do that when you go to a Google database and type in your ancestor's name, right? You may find that you need to learn something about a little village that your ancestor lived in, and you type that into a database to find out where that village is, what county it's in, something like that. If you want to learn what a tinkerer was, you find the word tinkerer on your ancestor as an occupation in the 1860 census, and you say, what the heck is a tinkerer? And you go to a dictionary database, dict.com, for instance, and type in tinkerer, and you get the definition. That's a keyword approach, okay? Keyword searching is very common in textual databases because you may be searching a wide amount of text, like a newspaper or an article someplace, and you want to find where somebody is in there, okay? The word, however, has to obviously be in the text, which means you have to think about what am I looking for, how is that word spelled, making sure that you're thinking about your mother's maiden name if you're in a database looking for her as a child, and not her married name, okay? If you don't find that word, ask yourself, well, it should be there, but I wonder if that text used a synonym, another name for them, okay? A carpenter might be called a joiner or a shriner, just to go back to the occupational concept, okay? So think about synonyms, think about alternate spellings, alternate names for your ancestor. How many of you have a German ancestor who is Johann Friedrich Gottfried Wilhelm Schmidt, okay? Plenty of names to choose from. My colleague at work this morning was talking about an ancestor he found in Sweden in some research, and she shows up in 7 different surnames based on her patronymic, her husband's patronymic, her father's patronymic, her husband's other names, and there's other spellings of her name. 7 different ways he found, not just ways of spelling, 7 different surnames that showed up. You've got to keep those things in mind and make sure that you know what keyword you're looking for. Be sure, of course, that you got the proper spelling, or in some cases, the improper spelling. Because your ancestors and the people who wrote their names down didn't always spell them the way you do today. And we all have that lesson. We've had that for sure, okay? If you're in a Windows environment, F, as in find, or in a Mac environment, Command F will give you an opportunity to find that on that screen. You can find that in your word processing program. You can find it in almost any web page. And that's one way to do a keyword search on any particular environment in computerized environment. So, keyword searching is probably not new to anybody. You might not know that's its name, but that's not new to you. Phonetic searching, then. We've probably all seen that as a genealogist, too. Names are found, particularly names, not just words, that sound alike. Names that may be spelled a little differently, but they sound similar, okay? This is typically available in fielded data, such as an abstract of the 1880 census at Family Search or someplace like that. The Soundex is the most common genealogically recognized system for phonetic searching. It's not the only one. There are others. The Soundex is a simple kind of naming code developed back in the 1930s or so and used by the federal government before there were even computers. And we still use it today because it is a simple way programmers can put it in fairly easily, and it does a fair to moderate job of combining names that might have a similar but slightly different spelling, but often mean the same name. However, there's also a system called the Metaphone. There's even a company called the double Metaphone. It's a more complex computer algorithm. If you want to read more about it, you go to a site called searchforancestors.com, and they have a nice description of a double Metaphone and the Metaphone system. But for instance, here's how it works. Neither of these are perfect. Take my ancestral name's Thompson. Thompson has a P in it most of the time. If I use a traditional Soundex, you'll see the first code up there, T512. That's how Soundex usually works for Thompson. But if somebody didn't put the P in Thompson, then it's going to code as T525. That means I still need to be aware when I'm using a Soundex algorithm that there may be multiple ways to spell it that aren't considered under the same Soundex code. And the Metaphone code has a similar problem. The Metaphone code is shown over there on the left-hand side of that right-hand side as you're looking at it, of the image there. And they use a 0 to represent the TH or the theta sound, or a null sign, and MPSN. But without the P, it still gets coded differently. So these systems still aren't perfect. In fact, there is no perfect system. That's why we use other systems, and we have to understand the difference. As a researcher, you want to make sure you find every possible spelling, and that way you need to know what the limitations are in a system. Here's an example of how the Metaphone system works at RootsWeb. If you go to their World Connect project, you can, over on the given name, or excuse me, the surname field, there is a box that says exact. That means I'm going to search for just that spelling of the surname. But you can put in other options. You can put in a Soundex choice. You type the surname in, the computer worries about whether it's a soundex, what the soundex code is. You can type in the surname and choose Metaphone, and it will do a different search using the Metaphone algorithm. See how that works? It may come up with slightly different results. Not a lot of genealogical databases use a Metaphone approach, but most do use some type of a soundex approach. And therefore, you need to be aware of how these systems work and what their limitations are. Another system that you're very familiar with, most of you, is the concept of a wildcard. How many of you have used wildcards in your searches before? Of course, because it's a real easy way to take care of spelling issues which might not always be consistent from one database to another or within a particular database. A wildcard really simply is defined as the use of a symbol to represent one or more letters in a word. It doesn't have to be a name. It could be a word. Okay. It is used in fielded and some text databases. It depends upon the nature of the text database and the, how shall I put this, the ability of the programmer, okay, and how energetic the programmer is in figuring out how to make it work with all that text. So that's important to understand. Often, different systems might use different symbols to mean replace just this letter with any one letter or replace this with more than one letter. For instance, a question mark is usually used if you just want one letter to be variable. For instance, if you take the name like Thompson again, I don't care about the P's for right now, but it might be that somebody spells it T-O-M-P-S-O-N and others S-E-N. There's a particular problem with Scandinavian countries. You might list Larson as L-A-R-S-O-N or L-A-R-S-E-N, depending on which country you're from. And you might want to say, I don't want a lot of variables. I just want to make sure that that vowel at the end could be an E or an O. And you put a question mark in there, and one letter can be there different than the other letter. On the other hand, if you put an asterisk in there, maybe they could put several letters in there, and that might give you a much different name that has a lot of letters between the S and the N. Okay? Sometimes they use an exclamation point. So you've got to learn with each database what is typical and what are they using for their wildcard symbol. The asterisk seems to be the most common, but in some academic databases, the question mark or the exclamation point shows up. So here is how you could do Thompson to eliminate the P problem, because in many databases, particularly at Ancestry, the asterisk means one or more or not any letters at all. So in other words, it can be T-H-O-M-S-O-N, there can be a P there, or there could be 16 letters there. Uncommon to have 16 letters in that name, but that's a possibility, all right? Truncation is another possibility. Most of you are used to truncation symbols, or truncation rather. In a truncation situation, the search engine is using a root of the word, or essentially the beginning of the word, and searching for all the words that begin with those same letters, okay? Usually there is a minimum number of letters, like 3 or 4 or something like that, that you have to have. Most databases don't want you to put an M there and get every single word in the database that begins with the letter M. And therefore, they're going to be limiting it a little bit, okay? It sometimes or oftentimes requires a symbol, and you can often find that you can put an asterisk at the end of a word, and that will allow you to truncate that word. But in many cases, it does not require anything. They will just simply say they'll look for that string and anything with that string and more after it. So for instance, and this is usually just in fielded data, okay, that you'll find that. And for instance, if you type in M-A-R-R, and if the database requires an asterisk or something, you put it there, M-A-R-R will give you Mary, or Marys, or married. Any idea why you don't want to stop at M-A-R? If you stop at M-A-R, you're also going to get the given name Mary. And if you're really trying to get words related to the word to marry, or the verb marriage, or the noun marriage, or something like that, then you're going to want to make sure you put the 2 R's in there before you truncate the word. So you need to think about that a little bit. Before you truncate the word, have you inadvertently put down the beginning of some other word that's going to give you many, many more hits than you want, more noise in your search results. That's something that you need to be watching for, okay? Here's an example from the Family History Library catalog. At the very top, you can see that I just typed in M-I-S-S-I. I didn't put a symbol in or anything. And in the place search routine in that catalog entry, it goes out there and brings me back everything the library catalog shows as a place which begins with MISSI. Now, Mississippi is the logical, most likely place, but you can see that British Columbia Mission is in there. The town of Mission in LaSalle County, Illinois is listed in there. Mission Canyon in Santa Barbara, California is listed there, all because those place names begin with MISSI. So for those of you who don't like to try to remember how to spell Connecticut, I was born there and I had to remember how to spell Connecticut, okay? C-O-N-N will call up Connecticut and some other things you probably don't care about, but it calls up Connecticut as well. So that's one way you use truncation because, number one, you may not be sure of the spelling of something, or it may be the spelling at the end of the word that's so variable that you don't know how to account for that. Well, if it's really that variable and you don't know how to use the wildcards appropriately or that doesn't work well, try a truncation search where you just begin with the beginning of the word. So I might be looking for Larson, and I could type in L-A-R-S as a truncated word, and that might do it for me. On the other hand, I might find a lot of words that have that same beginning. So truncation has its limitations, as does every one of these database search tactics. Now, phrase searching is a very popular one among genealogists, and partly because our favorite internet search engine uses phrase searching, and most search engines do, okay? With a phrase, it matches multiple words in the same sequence you type them in. Keyword searching, you can just type in a few words, and it will find all of those words, or maybe any of those words, depending upon the engine, in the text you're searching. With a phrase search, you're going to put it in and say, I want not just these 3 words, or these 4 words, or these 2 words. I want them in this order next to each other. I want this phrase to come back in all the hits that this engine sends me. Therefore, that's how you might search for a full name for somebody. Johann Ludwig Friedrich Gottfried Wagner. If that's how his name is going to appear in the database, and you want to make sure you only get that name, then you can do a phrase search for that name. There are significant limitations with a phrase search that everyone needs to be aware of, but it still is a very, very important tool. It is used in textual databases particularly, such as Google as a search engine. And Google really, when you think about it, is this massive database that simply is all the electronic text in millions of web pages. It does not index the entire web, but it is an index to a significant portion of the web, and it's really just text that is indexing, by and large. There are other issues that come into play. So, most of the cases, such as in Google, a phrase search is put in quotes. For instance, my grandfather, Arthur Percy Chamberlain, is a phrase search that can be done and find records that are relatively unique to him. There's not a lot of other phrases of people or names of people that are Arthur Percy Chamberlain. That's a wonderful thing about a unique name, is that if it's unique enough, most of the hits you get may well be the person you're looking for. However, it can also be too restrictive for good results. And that's something that each of you has to ask yourself. Have I restricted myself? And you're thinking, well, Kory, if your grandfather's name is Arthur Percy Chamberlain, isn't that how you'd want to search for him? Why wouldn't I want to search for him that way all the time? Why not? He might be Arthur P. Chamberlain, right? He might just go by a middle initial, all right? How about the name Chamberlain? Some people spell Chamberlain with L-I-N at the end and not L-A-I-N, all right? What if he's in a database of burials listed as Chamberlain, comma, Arthur P.? That's not the same phrase. It's not going to find him. Do you see how it can be restrictive? So you have to use these in combination and use different variables and different ways of searching things, okay? For instance, here is a Google search for Arthur Percy Chamberlain. Most of those hits are from him, okay? Born in 1892. There's a genealogy page there. If you look towards the very, very bottom, I had to include this because when I did this search a few years ago, I found him in some yearbooks from Yale. Down at the very bottom, you'll find out his nickname was Fish. You know, that never came across in the family history to me. And unfortunately, I learned this shortly after my mother passed away, so I never got a chance to ask him, why was your dad known as Fish? I'm not sure if she would have said, I didn't know that, but I'd say, well, Mom, it's in his college yearbook. And she'll say, dear, I wasn't born when Dad was in college. I presume he was a swimmer. What else would you do at Harvard to get called Fish? Or Yale, excuse me. Boy, did I just do a faux pas there for you New Englanders. Sorry for you Yaleys out there, okay? Boolean searches. How many of you have heard about Boolean searches? How many are comfortable with Boolean searches? All right. Take a deep breath. This is where search algorithms begin to get more complex and oftentimes a little less common. Actually, most of you have already done a Boolean search. Let me ask this question. How many of you have used Google once or twice in your research? All right. How many have put more than one word in that Google search box? Guess what? You've done a Boolean search already. Isn't that nice to know? You've been doing something important without even knowing what it was called. We do that all the time, don't we? Anyway, Boolean allows you to combine search terms in unique, sometimes ways, different ways to make it easier to find words that might show up together, okay? It's very common in textual databases such as search engines. Bing, Google, others like that will use Boolean search capabilities. It's a fancy name for a search technique where certain operators are used. Operators are the term used for the ways you combine different words in a search, okay? The three major operators in a Boolean search are AND, which is usually used with a plus symbol, or you might capitalize the word AND. It depends upon the search engine and the programmer and how they put it together. And that means that the result must have both or all of the terms that you've typed. And that's, for instance, what Google does automatically for you. You don't even have to put the plus sign in there or the AND sign in there. It will find it for you. Or means something totally different. It means I want to find either this or that in the database. And sometimes it's a symbol, the pipe symbol, the vertical bar on the keyboard. And that means it has to include either of those, but it doesn't have to include both. Now, this is very significant. How many of you remember back in the early dark days of the internet when there were search engines like Alta Vista and others like that, okay? In those early days, when there were only a few thousand web pages out there, the programmers got smart and said, you know what? We're going to make sure they get all the possible results they could, and if they type in 2 words in the search box, we're not going to give them a website if it only has just one of those words, because we're assuming that they might like that one just as much. And that was just fine when you wanted to sift through only 4,000 or 5,000 results. But nowadays, with millions of web pages and hundreds of thousands of websites, if not more, OR seems like an automatic OR is going to be really a lot of hits if it's going to give you every web page that has that word or that word on it. There are times in your research where you want to do that, okay? And then there is the not operator. Not is usually used with a negative symbol, particularly in Google, and that means that I don't want that term to show up. That term gets in my way. It's not pertinent to my search, and so if the search has that word in it, I know it's something I don't want. And so that's something you should use. Here's a Venn diagram, if you remember your old 8th grade math classes, that shows you the difference between these search capabilities, all right? So, AND means I want the intersection of those 2 words or those 2 terms. I want to make sure I just have both of them. OR means I want everything you can give me, either one of them. And NOT means I want everything of one of these except for this portion right here that includes this word. How does that have any genealogical bearing at all? Let's talk about this a minute, okay? Here's some examples of a Boolean search. How many of you have a Snow family or something like that that has one of those common words? I have an ancestor named Rust. Henry Rust. You ever try to do a search on rust? I can tell you all the great oils to unlock rusty materials. I can tell you all sorts of ways that rust is created, except how Henry Rust was created, my ancestor, all right? If you've got one of those ancestors that had a name that was a common word in the English language, you have a problem doing a big global search, don't you? And so if you use a combination of Snow and family, then you're going to find websites and materials that only talk about that. And that might limit your search. It should certainly limit your search to fewer hits to try to construct. If you know a person's name, you know his name is Ludwig Snow, then you can add that to it. And you can AND more than one thing. You can AND 2 or 3 or 4 things. And that's what Google would do for you. If you put in 8 words in that Google search box, it will try to find a website with all of those words. If it doesn't, it will warn you about that, and it'll give you options and things like that. I come from southwestern Michigan, and there's a lot of commerce and interchange between 2 counties there, Berrien and Cass County. So I might have to look for my family in both counties. And therefore, I might be doing a search where I want to look for either Berrien or Cass County. And I'm interested in results that have either of those counties in it, because my family might have turned up in either of those families, in either of those counties. So, or may have some bearing for you in your genealogical research. Not is a powerful term to sort things out. It doesn't work perfectly in Google and in some other big databases, but I've often had to use not Neville when I search for my Chamberlains. An idea why I need to exclude Neville? Why does Neville have anything to do with Chamberlain? Where's a World War II historian out there? Neville Chamberlain was the British Prime Minister before Winston Churchill. And according to my mother, who lived through this, Americans weren't excited about Neville Chamberlain because he seemed to appease Hitler too much. And my mother didn't like everyone assuming that because they were Chamberlains, they were somehow connected to Neville Chamberlain. So she said in their family, Neville was a dirty word. At any rate, there's a lot more Neville Chamberlains out on the web than there are Arthur Percy Chamberlains on the web. Okay? The downside is that Neville Chamberlain's first name is Arthur. So if I do a search for Arthur and Chamberlain, I'm going to get a lot of Arthur Neville Chamberlains. So I can combine these Boolean operators into Arthur and Chamberlain, but not Neville. Do you see how I can exclude 2/3 or 3/4 of my hits? Isn't that a slick trick? If you are going and doing a search on that Snow family, and you find Snow and family, but you're still getting a lot of other stuff, and you can say, well, gee, I'm getting a lot of stuff here about the weather or temperature. And you can say, all right, weather and temperature don't have a heck of a lot to do with my Snow family. And if I go Snow and family minus or not weather minus snow, excuse me, don't take out snow on your snow search, or minus temperature, you can begin to exclude the data that's irrelevant to your search, making your search results much more refined and useful for you. Now, I have noticed that Google isn't perfect yet. Anyone else notice that? I'm not here to trash Google. Frankly, I use it on a daily basis. I keep one screen on my 2 screens almost always open to Google or something for doing a search. But when I do this, Arthur and Chamberlain, not Neville, it knocks out 80 or 90% of the Nevilles. But a number of Nevilles manage to squeeze through Google's searches. I'm not sure how and why, and I'm not going to figure that out. But it still can be very helpful, and particularly if you're dealing with a slightly smaller database than Google, which is like every other database known to man, is slightly smaller than Google. And the database is more controlled. I don't want to say Google's uncontrolled, but if you're dealing in a database that's fielded data, it's going to be easier for the program to exclude some of that data. Whereas with the textual data that Google's dealing with, it might be harder for the program to exclude those terms. Okay. All right, field searching. Everyone feel better about Boolean searching now? All right? Those search engines which provide Boolean searching usually don't require you to put the and in there nowadays. Google's main breakthrough when Google was founded, was it 10 or 12 years ago, was that they did an automatic and in those searches when other companies were doing an automatic or. And therefore, people got results that included both terms. Google thought logically and said, you know, if Kory types in Arthur and Chamberlain, he probably wants both of those terms in the search results. And so they said that was one of the major breakthroughs, along with a lot of other good things that they did. But that's just an example of how they took a situation that wasn't working as well as it could and found a way to make it better. That's how we all progress in the field of genealogy, in the field of any science and any human endeavor. We build off of what others have done before us, and we find better ways to do that. And RootsTech is an example of that. You're finding new things from the people here, aren't you? The RootsTech conference, just 2 years old, built on an idea that started down at BYU years ago to have a computer conference. We take what we learn, we build, and we get better. And that's what we do in genealogy as well. And that's why I'm hoping there's a few programmers out there listening to me, because we're coming up on some search routines that most genealogy software doesn't use. And you're going to love it if you can see it in use, okay? Go to your nearest programmer and tell them about some of this stuff. Now, field searching is pretty standard, okay? It matches information in one or more fields. And this has been with database searching and database development since the beginning, because when you put a bunch of data into a database, you're putting things into fields. And in order to retrieve that data, you're going to want to retrieve the stuff that's in the fields, okay? So, fielded data is something you're very familiar with. How many of you have a genealogical database manager where you put your ancestors and relatives in? Okay? Not enough of you. Amazing. I'm sure there's some vendors out there that would have to talk to you about that. But the object is simple. You have a field where you put in a birth date or a death date. You have a field where you put in a place. You have a field where you put in a baptismal date or a bar mitzvah date, depending upon what fields are in your database, and that's fine, okay? Then you can retrieve that data. You can say, I want everybody born on this date or born on this year, things like that. And many of the databases we do searches in on the web, Ancestry databases and many others, have fielded data, okay? Most fields have preset options. For instance, if you're looking at an index or a database with the census, it will have a preset field for state. And you can say, I want only people that were living in Connecticut in the census, or born in Connecticut, or born in Connecticut and living in New York, if that's the type of algorithm or search you want to make. You might want to say, I only want only people who are listed as the head of the household, who are listed as a child or a son in the household. So you can limit, because there's some preset options. Because you know what? When you get down to gender, so far, there's only two. Okay? Either the person in that database is listed as a male or a female, all right? RuPaul notwithstanding. Search one or more fields at a time is an opportunity you have with a database. You can say, I want this particular given name, and I want this particular county, and all the people with that given name or in that county. I've used that numerous times with great success looking for German immigrants in North America that are hard to find. Consider this. Johann Wolfgang Schruber comes over and settles in Iowa. Okay? How do you spell Schruber? More better than that, or more important than that, how did the census taker spell it? And how did the indexer read it? Okay? I don't always find Schruber, okay? But I know he lived in Appaloosa County. I can go to Ancestry Search or many others and type in, choose the 1850 census. I can choose Iowa, I can choose Appaloosa, and I can put in no name at all in the name fields. And I can put in Germany in the birthplace field. And what's it going to give me back? All the people born in Germany who are living in Appaloosa County in 1850. And there might be horrors, 85 of those. That's 2 screen loads to sift through, isn't it? And the database will probably bring them back to me in surname order anyway. So I can skip to around the S's and see, do I recognize someone that might vaguely look like Schruber? I don't know which given name he's under. So field searching is a very, very powerful way to really dig down into a database when you have information that's not cropping up the way it should. You've done the search there by the name, you've done the given name search without a surname, you're still not finding it. But you know darn well where they live, you can do a search just in that locality. Or you may say, I did this once years ago, I was dumbfounded doing this search for this guy. He's supposed to be in Arizona, and he wasn't showing up in the 1910 census index for Arizona. And I said, what the heck? The name's not that common. I'm going to take off Arizona altogether and just search the whole country for this guy. He was in D.C. Now, I don't even think of D.C. as a place to search in most cases. Not that many people were living there. He was with the military, and he was back in D.C. for some reason. His family was there. You know, I would have never looked in D.C. specifically for him. But by pulling away the field of birthplace or residence at the time, then I was looking at a broader search. Now, normally, I don't search the entire country for a person if I know where they're supposed to be living, because I'll get too much noise in my search results. But if I'm not finding the person I'm looking for, go back to your set of fields in the database and ask yourself, what fields am I certain of, and what fields might be getting in my way? And close out. Don't search those fields that are getting in your way, and search the fields you're certain of. Okay? Now, remember, the more fields that you fill in fielded searching, the more restrictive your results will be. If you insist on putting their age in there, in a census search, in a field of data, you're depending on the census to have recorded the right age, and for it to have been recorded correctly and read correctly, and data entered correctly. We're going to talk about ranges in just a minute, but if you insist on putting a given name and a surname and a township and county and state in there, and a birthplace, you're going to get a very limited search results. Now, that might be useful if you're looking for John Smith, and you want to narrow it down to John Smith's in that township, born in Ireland. Okay? But be careful. If you don't get very many results, back off and search less. Okay? Most Ancestry databases are fielded searches. Not all of them, but most of them are. Some of them work better than others. Some of them are more discreetly fielded than others. For instance, the Civil War pension file index, which still frustrates me at Ancestry, is a huge, useful tool because it saves me trips to the library and calling up microfilm and things like that. But the name field is just one field. And I keep asking myself, let's see, do I put the soldier's last name in and then his first name, or his first name and his last name? Turns out it doesn't really matter. It's going to find them both. But it's just uncomfortable. I'm used to seeing fielded data that says first name here, last name there. But that's not always the case. And in fairness to Ancestry, who does pay me right now, not for this conference, but for my regular job, in fairness to Ancestry, that was their very first database that they converted from microfilm and did data entry on, and they were learning how much data do we take from those 3x5 cards from the index, and how do we present it. And it was so successful that they've done so many more, they haven't had a chance to go back and make that one improve, because they want to improve other databases as well and add more and more. This is what we love about all of our people out there putting data on the web, is that they are adding data on a daily basis, making it easier for us. All the more reason for us to make sure we clearly understand how to make the best use of all the data that they've gone through so much time and expense to create. Library catalogs are fielded data. And if you're looking for a book about somebody, you're going to fill in fields, like this image from the Library of Congress's catalog. Notice here, this is from their guided search, and I can search for a certain term, and I have an option of all of these, or I can, in this case, I want to search for all in the first box, all the terms I type in there, and I want those to be in the personal name field where an author's name would show up. So I could write in John Michener there if I'm looking for a novel or something like that. And if I want to, I can go to the next one and say, I want all of these terms in the title field. And then I can go to the last one and say, I want this phrase in the keyword search for that. Now that's a very narrow search, and it might be too narrow if I use all of those search capabilities. Usually you'll use just one or two. But this is an example of fielded data, and I just wanted to illustrate that you have an option to choose which fields it's searching and choose the nature of the search in those fields. So I'm saying I want the first search and the second search and the third search. That's a lot of ands in a lot of very specific fields, and depending on what I type into those search boxes, I might get a very, very limited result. But there are times when you might want that in a library catalog, or you just want something more basic. I want, in this library catalog, this particular author's, okay? I was teaching a class last night over at the university, and the question came up about a particular book that somebody had written. And we found it on an index we were looking at online, a reference. And the person wanted to know if the university's library had a copy of that book. So right there, I opened up the library catalog. I typed in, actually, I wanted to know if the Family History Library had the book. I pulled up the Family History Library catalog, typed in just the author's last name. It was uncommon enough, and got a list of books by that author. Got a list of authors with that surname first, selected that author, and bang, the book was there. That's all it takes sometimes. But again, you're dealing with fielded data, and stop and think, what do I know? If I don't know the name of an author, in this case, that particular search, we were actually looking for a family surname, and the family surname was crime or something like that, okay? Not one of those surnames you want to do too much looking for because it's got so many other words out there. But going to the surname search in the library catalog, there was one book or two with that book, and we were able to match what we found on an index list. So fielded data can be very beneficial for you. Now, limiting searches. There are a number of ways to restrict your search to certain parameters. We've already actually talked about it a little bit. By putting in fielded searches and filling in many fields, you are restricting or limiting your search. But there are other ways as well. And with fielded data, you can put information in a field and still limit it somewhat. For instance, one aspect of fielded searches is to say, I want this date range. I want, in a library catalog, you might say, I want books on this family that were published between 1900 and 1940. Maybe you're trying to, maybe you found some reference in a 1950s book, and you're figuring, did they copy that from something earlier? I want to look at earlier books about that family to see if they also are saying the same thing. So you might want to have a search of that nature. Many of the Ancestry databases do this very same thing. They allow you to limit your search to a number of years, for instance. It's very common, as I indicated, with library catalogs to restrict by author, restrict by the language of publication. I only want English language material. In fact, you can do this at Google as well. If you go into some of Google's preferences, I can say, I only want English language results. If you keep getting results from a foreign language in Google search because of that particular name that you're searching, you can tell Google, all right, I acknowledge that this is a Swedish name. I acknowledge there's a lot of stuff written in Swedish about it, but I can't read it, so please only give me English language results. And Google will comply because it's limiting you, okay? Here's an example from the Social Security Death Index at Ancestry. And if you go to the birth and death fields, you can put in the day, the month, the year, but you can also put a range of years in there. And this is one of the great new things about the new search at Ancestry. Us old guys who are using the old search are reticent to give that up. But Social Security in the old search didn't allow me to have a range of years to search for a death date. I had to know the year they died or the year they were born. This new search gives me the opportunity to say, well, I think they were born in 1909, but let's go plus or minus 5 years in that. Do you see how I'm establishing a range? I can limit it, or I can increase the limit or shrink the limit to the number of years or something that somebody was born. That's just an example of a number of ways in which fielded data can be limited to certain range of dates or things of that nature. For that matter, in a lot of Ancestry databases, you might have noticed that you have an option of saying soundex or exact search. That's a similar kind of limiting, isn't it? I can say I want just the spelling, or I can say I want the soundex version. And the soundex broadens it, and exact spelling limits it. So limits are a way that can be conceived of in a number of ways, okay? Proximity searching. This is the biggie that nobody's doing, more or less. This is the one I'd love to see more databases doing. I hope those programmers are out there listening, all right? Proximity searching is a very valuable way to say the search terms must be close to each other, but not necessarily next to each other. If they're next to each other, I can do a phrase search, okay? And you measure this proximity by the number of words, or sometimes characters, between the words that you want them to be. For instance, well, we'll talk about that. This is a very powerful way to search databases, but it's very rare in the genealogical field. Some textual databases do this, and we're going to look at one as an example. But the concept is relatively simple. They use a term such as within or near, and it says the terms can be in any order. For instance, I want the name William within 4 words of Plaskett. Because you see, William Plaskett often has a middle name, Leonidas. That's often fun, okay? The problem is he doesn't use it that often, so searching on Leonidas doesn't find him very well. But he also was William L., and his son was William Lucas. His grandfather, was William Lucas. And so I want all those Williams, okay? So I want William within 4 words of Plaskett. And just in case he's listed as Plaskett, William, I'm not saying which one comes before or after. Now, you can also, in some proximity searching, use before or pre, which means that one term must be before the other term. My wife grew up in Montana near a town called Stevensville. And if I'm searching for Stevensville, I want to make sure that it's Stevensville, Montana, because I grew up in Stevensville, Michigan. And so I want Stevensville pre-5 Montana. In other words, I want the word Stevensville to show up within 5 words of Montana, but it really ought to be before Montana because you're going to put Stevensville, Ravalli County, Montana, and there's already 2 words right there. And if Stevensville Town, Ravalli County, now I've got 3 words right there. So I can broaden that, say I want Stevensville within 5 words before Montana in a search that allows me to do it that way, okay? So this is a very powerful way to do searching. I hope you can imagine that already. Here is at GenealogyBank how you can do a proximity search. This is the only significant genealogical database I personally know of, and there may be others, and I would applaud others letting us know about them, that does proximity searching that can be so beneficial to genealogists. Not putting it in the name, in the last name or first name place, but in the include box, I put Chamberlain near 10 Meyerink. Chamberlain is my mother's maiden name. Meyerink is her married name. And doing that located a document I never even thought to go after, my grandmother's obituary. And it shows up because Harriet Meyerink is one of her daughters, and Gordon Chamberlain is one of her sons. Her husband, Arthur P. Chamberlain, is listed there as well. Okay? So, because Chamberlain and Meyerink are within 10 words of each other, GenealogyBank found this. And then I hurried back and said, yeah, but they would have found that if I just typed in Harriet for a given name and Meyerink for a surname, and for some reason it didn't. So here's another issue. When you're dealing with text databases, especially OCR databases from newspapers. Now, this one's not OCR. This is electronic text from the newspaper in 1989. For some reason, it didn't pick up Harriet Meyerink because she's not the subject of the obituary, apparently. I can't say why it didn't. I'm going to go talk to the GenealogyBank people a little later and just ask them why, so I understand the database better. At any rate, because I broadened the search using a proximity combination, I found this. In that very same search, I found out that in 1960, my older sister Gail was living with her grandmother and went to visit her cousin up in Pittsburgh. There was a newspaper article from 1960 that talked about Ruth Chamberlain and her granddaughter, Toni Gail Meyerink, had gone to visit her sister-in-law up in Pittsfield, Massachusetts. Little pieces of family history I never knew, just because the names are close to each other in a newspaper account. Does that look slick to you guys? Tell your favorite programmer you want this kind of data out there, and look for that kind of data in the databases, okay? String searching, another important tactic, okay? This means you match consecutive characters, not necessarily words, there often are, but they could be letters, they could be numbers, they could be symbols. Most of the time in genealogy, they're going to be names of people, but for instance, it's usually used in text fields, sometimes in fields of data, and it shows up in a variety of ways. It's not always called string searching, but that's what it ultimately is. Here's an example on my wife's family on the Kleinsmiths in Pennsylvania. As you can imagine, with a name like Kleinsmith, it shows up with a CLI and a KLI several times, in the same record sometimes. And so if I don't want to do a search for both different spellings, I can say, look, what do these spellings have in common? In this case, it's the Einsmith spelling. And there's even some differences there, but for this purpose, we're going to do that. And if I do that search, I can find both spellings and some other names, okay? If you want to do this at Ancestry, there's a very powerful way that they've evolved that. You need to have a wildcard character to do that. And I can put asterisk in front of Einsmith, and Ancestry will find it. We're going to see that in just a minute. You need a minimum of at least 3 letters, okay? And at least one of those letters has to be beginning or the ending letter of the name. How many of you are aware of that search algorithm at Ancestry? It's a very, very powerful way. You can have multiple wildcards in there if you want to, but if you have at least 3 letters, and one of them is the first letter or the last letter of the name, you can do that kind of a search, okay? Fascinating way. So for instance, at Ancestry, if I do this in the 1850 census for Pennsylvania, you can see in the little circle at the top what my search was. It was asterisk INESMITH. And the results of this came up with some Brine Smiths, I never heard of them before, but many Klein Smiths, and further down the page you'll see Anthony and Andrew Kleinsmith with a K. Now Ancestry was kind enough to alphabetize the last names for me, so if I have a large hit list, I can then go through and go to the part of the alphabetical section that I expect that name to be in. So for instance, there were several other names that ended in Einsmith that began with D or F or G or something like that. Then I could just skip past those and jump down and see the Ks. So that's another important issue is when the results come back to you, what order are they filed in? They're going to give you all the results that meet your search algorithm, but if there's more than 2 results, it's going to be filed in a certain order. If there's 2, they're going to be a certain order. And that order will change based on the database, based on the programmer, and what the developers decide is the most important thing you want to learn from that database. And usually it's the name of the person. All right, controlled vocabulary searching is another important thing that you're already doing. In most of your searches, many of your searches, you're already using what's called controlled vocabulary, and that's where the database developers have decided for you in advance what words are going to be filed where, what names and what topics, for instance. This is where the search terms are prescribed in advance. Library catalogs work like that, okay? It is pretty much unique to fielded data, where you were told what fields or what data you can have in those fields. These are what subject headings are in a library catalog. If you want to find a family history about the Jenkins family in the library catalog, there are certain ways to do that. If you go to the subject section of the catalog, you need to type in Jenkins space family. That's how libraries work. You don't type in Jenkins, comma, Samuel. That'll find books about Samuel Jenkins, but not necessarily what you're looking for. You don't just type in Jenkins. You should have to type in the right cataloging, Jenkins space family, and that's because that's how they've limited and controlled the vocabulary for that, okay? And therefore, you have to learn what databases are using what words. For instance, your database want the word tax records rather than ratables or assessment, two other words that mean tax lists. Your database might want to use the word probate rather than the word will, or vital records, not birth certificates. So that depends upon the database and what their controlled vocabulary is. Here's an example from Heritage Quest's index called PERSI, the Periodical Source Index. And what I've done here is under the record type, down at the bottom of the search boxes, I pulled up for you the drop box which tells you these are the only record types we allow in PERSI. What that means is they're not excluding articles. Every article that they index has to be under one of those categories, okay? That's why they have an other records category, in case there's something they didn't think about when they put this list together, okay? But you can see that they don't have anything for birth certificates. You have to come down and look at vital records for them, okay? So they don't call it tombstones, they call it cemeteries. Now, that might be fairly logical. That's just general jargon in the genealogy world. But on occasion, we're dealing with a database that might not have been done for genealogists. They may use slightly different terminology. So you need to be asking yourself, am I using the right vocabulary? In most cases, the database will tell you what words are optional or usable in those fields. But on occasion, you need to be looking a little more closely. All right, another search option is called nesting or grouping. This is an advanced Boolean search technique. We talked about Boolean search a few minutes ago. And that's pretty simple, the and, or the or the not. But sometimes that's not enough in a complex search where you're trying to hone your results down to very specific findings. And it does require you combine some things before other things. This is getting back to that high-grade math you learned back in junior high. Algebra, okay, where you combine some terms before you do other terms, multiplication before addition, whatever those things are, okay? It's usually used in textual databases because you're looking at a whole bunch of words or text. So Google and Bing and other search engines use this kind of thing, okay? So for instance, if you have an ancestor living in California, and you're reading obituary, and it says something about the ancestor was born in Paris, but you know he wasn't born in Paris, France, but you're not quite sure where he was born. Where are the Parises in America? Or you decide after doing a gazetteer search that there's a Paris in Ohio, and there's a Paris in Texas, and a lot of people in that county he was living in California came from both those states. You could do a search for Paris and either Ohio or Texas, okay? You've got to be very careful if you don't put those parentheses in there and nest that first search first. Because what the search engine is going to do is going to say, I'm going to go out there and find all the things that have Ohio or Texas in it, and then I'm going to take any of those that also have Paris in it. You see what I'm saying? If you took out those parentheses, you're going to have everything that has Paris and Ohio, or anything that has Texas at all. To see how the different search results would be? I could draw a Venn diagram for you then, but that's even more boring and geeky, okay? So if you're looking for the Snow family, you might decide that family is not the only word that might be useful. If I put family or genealogy, I'll broaden my searches a bit. That way I'm getting snow and genealogy along with snow and family, but I didn't have to do two separate searches. I nested the one search inside the other search, okay? So, that being said, let's take our last few minutes and review this concept of the different search techniques in general, okay? We talked about a dozen. I know your brain is exploding right now, okay? That's why they're listed in the syllabus, so you can go back and review them, all right? Use some of these and test them, but as you search databases, here's some other things to keep in mind. In most of your searching, less is more, okay? The less you put into a search, the more results you're going to get. That can be good, that can be bad. Okay? Depends upon your search and the database you are searching. Second of all, choose the right field. That's not a baseball concept, okay? It's a genealogy concept, okay? Make sure when you're doing fielded searches that you're searching the fields that you're most confident of and will give you the most precise results. That might mean you're searching my birthplace in a county without a birth date or a name at all. It might mean that you're searching for that uncommon surname in every country in the world, if possible. Okay? Then, look for search terms or search help somewhere buried in some tiny little link, hopefully on that home page where that database is, upper right-hand corner, lower bottom, some places there. The programmer said, you know, we put to a lot of work to put some complex search algorithms in there, but almost everybody wants to use basic search. We want a nice, clean interface, so we only put the basic search up there in front on the first screen. And the basic searches are maybe a keyword search, and maybe you can use truncation or not. And they don't tell you right up front all the different ways you can do that searching. Look for search tips or search help somewhere, a link that will explain this to you. We're going to show you a screenshot in just a minute. Look for specifically the advanced search options. Usually that'll be right there with the basic search you're faced in that screenshot, but the advanced search will be there as well. Explore that advanced search. What other ways can I explore this database that would give me a more meaningful results list? Consider alternate terms. What else might the name be filed under? What other county might it have been before it was this county? Make sure you look that up. If you're getting no results for Calhoun County, maybe it wasn't a county in that census year, and you need to find out when Calhoun was created and then go search the other county. So do that. And that also means experimenting with the data. If you're not getting the kind of search results you want, you think, this is ridiculous, they must be there. Do some experimenting. There is a county in New Hampshire, Grafton County I believe it is, that is missing for the 1810 and half of the 1820 census. Now, if you're doing research in New Jersey or Virginia, you're used to not having those census records. They've been lost for years. When you're doing research in New England, you expect it's all there. It usually is. But for Grafton County, it's not. I learned about this some years ago looking for somebody in the 1810 census. I knew they were there. They were there in, later. They were there earlier. I had birth records, but they weren't showing up in the census. I said, that's odd. Did they even count Grafton? Was Grafton a county? Or maybe the indexer had it, in some other county. In old days, they had all sorts of mistakes like that. So I did a search, no names at all. I just put Grafton, New Hampshire in there, and I got 0 hits. What's that tell me? That for whatever reason, Grafton isn't there. You're right. Whether they've got it under another name, but it alerted me that I needed to do a little more backup, a little more research, a little more finding out about it. So do that, and then learn what is permitted for that database. What will they allow you to search? What data? Some fielded data can't be searched in some databases. It's fielded, but the search algorithm doesn't do that, okay? Here is, from GenealogyBank again, the help page. Over on the upper right-hand corner, you can see the word help. Over on the left-hand side, help has advanced techniques. And here you can learn about phrase searching, Boolean operators, proximity operators, wildcards, all the things that aren't on the simple introductory page for GenealogyBank. So here's an example for you, okay? If you're dealing with library catalogs, understand you're dealing with fielded data. They use a controlled vocabulary, and they usually have a standard search and an advanced search. When you're dealing with search engines, typically, internet search engines, you are dealing with full text. Keyword searching is usually very common. Boolean searching is supported. Oftentimes phrase searching and some limited truncation searching. Google provides synonym searching. It'll find synonyms for you. And Google provides a search called wild word searching. In a phrase search, you can replace a word or two of that phrase with the asterisk. So instead of finding 3 blind mice, it'll find 3 white mice, 3 dead mice, and things like that. Not that that's really genealogical, but it will be useful looking for Arthur Percy Chamberlain. Okay? Look for alternate database versions. Social Security database is out there on about 8 different databases, okay? Census indexes, many censuses are at 4 or more different websites. Cemetery listings, there may be collector sites like Find a Grave, but there are local sites as well. Watch for that. Here's an example of cemeteries. Mound Valley, sometimes called the Perry Ward Cemetery up in southern Idaho, is on 2 different websites, 2 different transcriptions of it, which has variable information. Over on the left is from a Gen website for that county, and it lists the people just name and birth date and stuff. Over on the right, interment.net gives more information, and the author indicates that she has gone to the cemetery records. I don't know what she means quite by that, because it's in a farmer's field, literally overgrown. But the issue here is simple. 2 different people did it. 2 different sources are there. One might be easier for you to search than others, and that's the key concept. Database searching is critical, because what you don't know might just hurt your results list. Thanks so much. Enjoy the rest of GenTech.